Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the CDF and PDF of a continuous random variable, and we'll use this to calculate probabilities. So we're only looking at continuous random variables, and each of the ones we look at will have both a PDF, a probability density function, and a CDF, which is a cumulative density function. So these concepts are overlapping but distinct. They're very similar. The PDF calculates the probability that the random variable is within a range of values. Now remember, if a random variable is continuous, the probability it takes a specific value is always 0. So we can only calculate the probability that it's within a range of values. The CDF, on the other hand, calculates the probability that the random variable is less than a certain value. Of course, these two things here will be the same because the probability x takes a certain value is 0. So there's a very close relationship between the two. If you integrate the PDF function from 0 to x, you have the CDF function. So in order for the PDF to be valid, two conditions must be met. So I'm going to sidetrack and just explain what this notation means. So this says little x, so remember large X means random variable, and little x is the values it can take. So this is saying the little x, the values the random variable can take are between m and n. If we use a round bracket, we don't include those values, and a square bracket we do include. So this notation says that x can take any value between m and n, but not including m and n. So this obviously says that the integral from the lowest value that x can take to the highest value x can take must be equal to 1. Another way of saying that is the area under this curve for all possible values of x must be equal to 1. That's the first condition that must be met for a function px to be a valid PDF. The second condition that must be met is if you substitute any value of x within the range of possible values into the function, you must get an answer greater than or equal to 0. This function can only return values greater than or equal to 0 for x in the range of possible values. All right, let's put all this into practice. So we're going to start by turning this function here into a valid PDF. So let's check if it satisfies the two conditions. So firstly, looking at the second condition, that's already satisfied. You see here, this says x is between 2 and infinity. It just means x is greater than 2. If I substitute a number greater than 2, a positive number, into this formula, I will get a positive answer. Positive number to the power of 5 is positive. 1 divided by a positive number is positive. So the second condition is satisfied. Let's check the first condition. So that's saying if I integrate from the lowest possible value to the highest possible value of x, if I integrate this function, I should get 1. So how are we going to integrate 1 over x to the power of 5? So remember, what we can do is rewrite 1 over x to the power of 5 as x to the power of minus 5. So then we just use the rule, we increase the power by 1 and divide by the new power. So I'm just going to write that a bit easier. I'm just going to move the negative power to the bottom and write it with a positive power. So what I need to do is evaluate this at 2 and infinity. Now we haven't actually done integrating to infinity before, but it's actually really easy. We're just going to substitute this into this function here. So if I substitute infinity, I get minus 1 over 4 times infinity to the power of 4. Think of infinity as a really large number. If you divide a number like minus 1 by a really, really large number, that becomes 0. So k, any number divided by infinity equals 0. If you take a number and divide it by a really, 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 really large number, it gets closer and closer to 0. So now let's substitute 2 into this formula. So I get minus 1 over 4 times 2 to the power of 4. I actually end up getting 1 over 64. So when I've integrated this, I haven't got 1. Instead, I've got 1 over 64. So how could I change this so it's a valid PDF? Well, the second condition was satisfied. To make the first condition satisfied, I can just times this by 64, because then the area will be 64 times this, which equals 1. So all I'm going to do to make this a valid PDF is times it by 64. That will now be a valid PDF because it will satisfy both conditions. So now let's use this to find some probabilities. So this is the function we calculated on the previous slide for this range of values. Really, this range just says that x can be any value greater than 2. So this is the graph of the PDF that we found. So because it's a valid PDF, this area under the curve is equal to 1. But note, if I substitute x equals 2 into this function, I get 2. You see, the value along this y-axis is not the probability, so the value along this y-axis can be more than 1. The value along this y-axis is really just a density, hence why it's called the probability density function. You see, I can't just draw a line up here and say, okay, well, the probability at 2 must be equal to 2. The probability from a PDF is found by calculating areas, and the area of a line is always 0. That's why the probability that x takes any specific value is equal to 0. So how do we calculate probabilities? Well, we have to calculate probabilities within a range like this. So I can calculate the probability x is between 2.5 and 3. The way I do this is by finding the area under the curve between these two values. Of course, this area will be less than 1 because the whole yellow area was equal to 1. So the way that you find the probability that x is within a range of values is you integrate the PDF between those two values. So I'm going to integrate 64 over x to the power of 5. So we're going to integrate this in the usual way, write it as 64x to the minus 5, increase the power by 1, divide by the new power, and I end up getting minus 16 over x to the power of 4. So I'm going to evaluate it between these two values. You can use your calculator to do this. You should get an answer of about 0.212. So again, don't worry about the number along this axis. It's not the probability. To find the probability x is within a range of values, you simply integrate the PDF between those two values. All right, how do we get the CDF? So the CDF is a function. So we should end up with an answer that is a function of x. So the CDF is the integral from the lowest possible value, in this case 2, up to, we'll just call it x. So we integrate the PDF again, but this time between 2 and x. So it's going to be very similar to what we've just done. We'll still get minus 16 over x to the power of 4 for the integral, and I should remember to write the dx there. So this time it's going to be between 2 and x. So if I substitute x into this function here, I just get exactly what you have there, minus 16 over x to the power of 4. If I substitute 2 into this function, I get minus 16 over 16, which is negative 1. So the CDF, this just becomes a positive 1, is just 1 minus 16 over x to the power of 4. Once again, x has to be greater than. What have I actually found? This, as I said, is a function. If you substitute any value for x, where x is greater than 2, this will tell you the probability that x is less than that value. And I substitute x is 4, 16 over 4. And if you put that on your calculator, you get 0.9375. What have I calculated? I've calculated the probability that x is less than 4. That's what the CDF calculates. The probability the random variable is less than a value. So on my diagram, the probability x is less than 4 would be all of this area here. It would be 0.9375. So again, the CDF is a function, so you should get x's somewhere, and if you substitute a number for x, it will tell you the probability that x is less than that number. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.